China's memory crisis is spreading into a part of the semiconductor industry most people barely notice. A Chinese supplier called Giantec Semiconductor has reportedly told distributors that prices across its entire NOR flash product portfolio will rise by 25% beginning July 6th. The increase applies not only to newly signed orders, but also to outstanding orders that have not yet been delivered. That is a major move for a component that usually receives far less attention than RAM, high-bandwidth memory, or solid-state drives. NOR flash is the small, reliable memory that stores firmware, boot code, configuration data, and essential instructions inside cars, routers, industrial machines, communications equipment, and countless connected devices. Without it, many electronic systems cannot even start. Contract prices for mature memory products have already surged sharply during the first half of 2026. Artificial intelligence infrastructure is absorbing investment, factory space, and customer attention. Automotive and edge AI systems are demanding larger amounts of dependable embedded memory. And now one Chinese supplier is adding another 25% to its price list. The question is whether this is a temporary adjustment from one company, or whether the global memory shortage is moving into the overlooked chips that keep the world's electronics running. What NOR flash actually does? NOR flash is not the same as the DDR5 memory inside a gaming computer. It is also different from the NAND flash used inside an SSD or smartphone storage drive. The easiest way to understand NOR flash is to think of it as instruction memory. When a device powers on, it needs a trusted place to find the first code it will execute. That code may initialize the processor, check connected hardware, load safety settings, verify security keys, and prepare the operating system. NOR flash is well suited to that job because it keeps data when power is removed and allows fast, direct access to stored instructions. A vehicle may use NOR flash inside electronic control units, infotainment systems, driver assistance computers, cameras, radar modules, telematic systems, and digital instrument clusters. A network switch may use it to store boot firmware and configuration code. An industrial robot may depend on it for control software that must survive vibration, heat, and years of continuous operation. A product containing powerful processors and expensive sensors can still become unusable if its boot memory is missing, unreliable, or delayed. Why prices are rising now? Mature memory products such as NOR flash and SLC NAND are often manufactured on older process technologies. Those production lines remain useful, but they do not generate the same excitement or margins as advanced AI memory. Large semiconductor manufacturers are investing heavily in high-bandwidth memory, enterprise SSDs, advanced DRAM, and newer NAND products. Those categories are being purchased in enormous quantities by cloud companies building AI infrastructure. Factory equipment, engineering teams, capital budgets, and wafer capacity are therefore moving toward the products with the highest demand and profit. But suppliers have little incentive to build large amounts of new mature node capacity when investors and customers are focused on AI. Modern cars contain more electronic systems than ever. Digital cockpits, advanced driver assistance, connectivity, over-the-air updates, cameras, radar, battery management, and intelligent lighting all require firmware. Edge AI devices also need more local code because they process information near the user instead of sending everything to a distant cloud. As software grows more complex, manufacturers move toward higher-density NOR flash products. That creates pressure on a market where supply is already becoming less flexible. The 25% increase. According to current industry reporting, Giantec's new prices take effect on July 6th. The increase covers the company's full NOR flash portfolio and applies to both new orders and undelivered existing orders. Normally, customers may assume that an accepted order protects them from a later price adjustment. Applying the new price to outstanding shipments suggests that the supplier sees the market tightening quickly enough to reset terms immediately. It does not mean every NOR flash manufacturer has raised prices by exactly 25%. It does not mean every chip buyer will pay the same amount. Large customers may have long-term contracts, negotiated allocations, or different product mixes, and a 25% increase in one component does not mean the final price of a car, server, or router will rise by 25%. The decision signals demand strong enough and availability limited enough to raise prices across an entire category without waiting for the next pricing quarter. A broader memory shock. TrendForce says contract prices for NOR flash and SLC NAND rose by more than 100% during the first half of 2026. It expects additional increases during the second half because major new capacity is not arriving quickly. When demand suddenly rises, Manufacturers can sometimes solve the problem by running existing factories harder or releasing inventory. That becomes difficult when the underlying production base is shrinking. Mature memory is not the highest growth destination for semiconductor investment. High-bandwidth memory can sell for far more than a small embedded flash chip. Enterprise SSDs are being purchased through large, multi-year agreements. Advanced server memory is receiving priority because cloud companies are willing to pay to secure supply. The result is that mature products can become scarce, even when total global memory investment is rising. The industry is building more memory, but not necessarily the specific kinds every customer needs. Why cars are exposed? Automotive companies are especially vulnerable because they cannot replace a qualified memory chip overnight. A consumer gadget manufacturer may redesign a board or switch suppliers relatively quickly. A vehicle component must pass demanding validation for temperature, vibration, reliability, and long operating life. Changing one part can require new testing, software verification, documentation, and approval. Automakers also need predictable supplies for many years because vehicles remain in production and require replacement parts after sales end. This dependence gives approved suppliers more pricing power when capacity tightens. Driver assistance systems need firmware for sensors and processing units. Connected vehicles need secure boot functions and update mechanisms. Higher levels of automation can increase the number and complexity of electronic modules. A shortage of relatively inexpensive NOR flash can therefore interrupt production of a much more expensive vehicle. Factories were forced to slow or stop because one missing controller or memory device prevented an entire car from being completed. AI servers are next, but with context. The title says cars and AI servers are next. That does not mean NOR flash will replace HBM or become the largest memory cost inside an AI server. Servers, network switches, accelerators, storage controllers, power systems, and management boards all require firmware. As AI data centers expand, they install enormous numbers of devices that must boot, authenticate, communicate, and recover reliably. Every additional server rack contains many embedded systems. The amount of NOR flash per device may be modest, but the number of devices is growing rapidly. AI clusters depend on high-speed switches, optical modules, smart network cards, and management controllers. These systems use dependable code storage for startup, configuration, diagnostics, and updates. Edge AI hardware creates another source of demand. Cameras, robots, industrial computers, vehicles, and smart appliances increasingly run models locally. That requires more sophisticated firmware and often larger embedded memory capacities. So AI contributes to the shortage in two ways. It pulls investment toward premium memory such as HBM and enterprise NAND. At the same time, it increases demand for the smaller firmware chips used throughout the infrastructure. China's position. Giantec is not the largest memory company in the world. Samsung, SK Hynix, Micron, Kioxia, and other major suppliers control far larger portions of global memory production. But China has been expanding its presence in mature and embedded semiconductor categories. That matters because domestic customers want secure supplies for vehicles, communication systems, industrial equipment, and consumer electronics. Chinese technology companies are also trying to reduce dependence on foreign components where possible. A stronger domestic NOR flash industry can support that goal. Yet higher Chinese prices show that localization does not automatically mean cheap supply. Domestic manufacturers still respond to capacity, demand, equipment costs, yields, and market conditions. If Chinese automakers and electronics companies compete for the same limited output, prices can rise inside China even while production expands. The shortage could benefit suppliers through higher margins. It could also encourage investment in additional capacity. But new semiconductor output takes time. Equipment must be ordered, installed, qualified, and operated at acceptable yields. Customers must test the finished chips. The market may remain tight long before any new line reaches meaningful volume. Duchu pays the final bill. The immediate buyers are distributors, module makers, electronics manufacturers, and system suppliers. They must decide whether to absorb the higher cost or pass it onward. For an expensive vehicle or server, one NOR flash chip may represent only a small fraction of the final price. Manufacturers may instead accept lower margins. They may negotiate with suppliers, reduce inventory, delay projects, or redesign future products around alternative parts. Smaller companies have fewer options. They purchase lower volumes, possess less negotiating power, and may not have second sources already approved. They could face longer delivery times or steeper price increases. The most serious risk is not the added cost of one chip, it is interruption. A missing component can delay an entire board, controller, machine, or vehicle. Companies may therefore pay a premium simply to guarantee allocation. This behavior can make the shortage worse because customers order earlier and hold more inventory than usual. What could end the shortage? Several developments could weaken the price surge. Demand for AI hardware could slow. Automotive production could weaken. Customers could reduce memory capacity or redesign products to use alternative devices. Manufacturers could reopen older lines, improve yields, or shift capacity back toward mature products. Chinese suppliers could expand faster than expected. But each solution has limits. Redesigns take time. Automotive qualification is slow. Building capacity is expensive. And suppliers may prefer to keep production disciplined rather than create another oversupply cycle. Memory companies remember what happens when too many factories chase temporary demand. Prices collapse, inventories rise, and expensive equipment sits underused. That history encourages caution. The market may eventually balance, but buyers should not assume prices will return quickly to previous lows. What this does not prove. One supplier's notice is not proof that every electronics category faces an immediate crisis. Giantec's increase must be separated from broader claims. We do not know the exact price paid by every customer. We do not know how much inventory distributors currently hold. We do not know whether competitors will match the full increase. And we do not know how long the new pricing will remain in place. The report is best understood as evidence that pressure has reached another memory category. NOR flash was once treated as a stable, mature component. Now it is being affected by the same forces reshaping DRAM, NAND, HBM, and enterprise storage. AI demand is changing investment priorities across the entire memory supply chain. My take is that the 25% increase matters less as an isolated number than as a warning. The memory supercycle is spreading outward. It began with the obvious products: HBM for accelerators, server DRAM, and enterprise SSDs. Now pressure is reaching the smaller chips that store the code required to start cars, routers, robots, and industrial systems. These devices are not glamorous. They do not appear in benchmark charts. Most consumers will never know which company made them. But modern hardware depends on them. Giantec's decision shows that mature memory can become strategically important precisely because the industry spent years treating it as ordinary. Supply is limited, qualification is slow, demand is becoming more sophisticated, and manufacturers are focusing investment elsewhere. That combination creates pricing power. The final impact may not be a dramatic 25% increase in the price of a car or server. It may appear as delayed production, smaller margins, redesigned products, and manufacturers paying more to secure guaranteed supply. China's domestic memory industry could eventually add enough capacity to ease the pressure. But today, one of its own suppliers is signaling that the shortage remains strong. So what do you think? Is the NOR flash increase another temporary spike? Or is it proof that the AI memory crisis is reaching every layer of modern electronics? Let me know your view in the comments. And subscribe to Eastern Engine for more grounded coverage of the chips, factories, and engineering decisions reshaping the global economy. Because the next hardware bottleneck may not be the processor everyone watches. It may be the tiny memory chip that tells that processor how to start.